Today's problem was submitted by a viewer, and it says, show that for x positive, x to the power of 1 over x has its greatest value when x is equal to e. Hence, or otherwise, but without use of calculator, determine which is greater, e to the pi or pi to the e. Okay, so I've seen questions like this before. We're going to take our function f of x is equal to x to the 1 over x, and we're simply going to maximize this using standard calculus. Let me write this as y is equal to x to the 1 over x. So the first thing we'll do is say that log of y is equal to the log of x to the 1 over x. And so log of y is equal to 1 over x log x. And now we'll differentiate and use implicit differentiation. I always assume we're using natural logarithms. So this gives 1 over y times y prime. Derivative of 1 over x is negative 1 over x squared. Plus, and then derivative of log x is 1 over x, so 1 over x squared. So y prime is equal to 1 minus log x times y over x squared. Okay, and we want this to be equal to 0. We want to solve for x where this is equal to 0. This is clearly always positive. The function y itself is always positive. I guess we should have said x is positive. So this is always positive. So the only way for this to be equal to 0 is if that is equal to 0. So we need log x to be equal to 1, which says that x is equal to e. Okay. So f prime is equal to 0 only when x is equal to e. So to see that this is a maximum, I guess technically we would have to take a second derivative, wouldn't we? Let me think, or see if there's another way to argue that this is a maximum. Maybe there's something we can say about limits. Well, maybe we just look at this equation here. Let's look at that equation there. As x goes to infinity, that goes to 0. If x goes to infinity, that goes to 0. So y approaches 1, I suppose. And f of e is equal to e to the 1 over e, and that's greater than 1. So if you think about what this has to look like on a plot, there's only one critical point. There's only one point where the derivative is 0, and that's when x is equal to e. Okay, but as we take a limit, so this number is whatever that level's at is greater than 1. But as we take a limit as x goes to infinity, y has to approach 1. And so it's going to, it has to do something like that. And so clearly, unless there's some kind of strange inflection thing going on here, how would we show that to the left? What if I evaluate f of 1? Oh, f of 1 is also equal to 1. So there's another point that the function has to pass through. And it can't turn around again because there's only one value of x where the derivative is 0. So I don't know what the limit is. As x approaches 0 of this expression, I don't know what the limit is. We could probably figure that out. So as x approaches 0 of this, that goes to negative infinity. That goes to positive infinity. So the whole thing goes to negative infinity. Y goes to 0. So I think it'll look something like that. So there's the maximum when x is equal to e, and that's the value of the function, e to the 1 over e. So the second part of the question asks us about e to the pi versus pi to the e. Okay, yeah, so I've done questions similar to this before as well. What I'm going to do is I'm going to assume e to the pi is greater than pi to the e, and either, okay, here's how, a better way of doing this. X to the y versus y to the x. So x to the y is greater than, let's go strict, greater than y to the x if and only if y log x is greater than x log y, if and only if log of x over x is greater than log of y over y. As long as x and y are both positive, right? We're assuming x and y are both positive. So I didn't multiply or divide by a negative number anywhere. So log x over x is greater than log y over y, if and only if this is true. And this function, is that the function that we minimized? Yes, right? Log x over x, log x over x. So log x over x has max value at x is equal to e. So this says that log of e over x is greater than, log of e over e is greater than log of pi over pi. Pi is greater than e. Well, it doesn't even matter that pi is greater than e. This has its maximum value at e. So now we can rearrange this. We can basically just go back up. So let's write this as pi log e is greater than e log pi. So log of e to the pi is greater than log of pi to the e. And so e to the pi is greater than pi to the e. There we go. Yeah, I didn't have to... The original thing I wrote down, I just sort of didn't know how to exactly communicate my thoughts properly, but this will show it. It's a question of understanding that the equation we're asked about, something similar to this, is equivalent to this. And this is more or less exactly the thing that we had maximized before. In fact, if we rewrite this, this is the same as log of x to the 1 over x greater than log of y to the 1 over y, which is the same as x to the 1 over x greater than y to the 1 over y. I just sort of, so we could have used this idea, let x be equal to e and y be equal to pi. Like this thing is maximized when x is equal to e, right? We saw that before. So if I set x equal to e and y equal to pi here, we have a true statement. And then we just undo these steps to get back up to here. But so more or less the same thing, just maybe sort of a different set of set of computations to get there. Yeah, so if you ever want to impress people, you can ask them which is bigger, e to the pi or pi to the e, and you know what the answer is now. Cool question. Thanks for the submission, and thanks for watching.